Hello, my dear students. This is Dr. Mohga, and today we're going to talk about the lesson of moment. In this lesson, we're going to understand what moment is, its equation, real-life applications, and how moment can be used or derived when applying one force at each side of a pivot, whether it is at equilibrium or not. Let's start with what a moment is. The moment of a force is the turning effect produced when a force is exerted on an object. Example, if a child is on a seesaw, if I'm turning the handle of a spanner, a door opening and closing. As you can see, all these examples have a relationship of going in a turning effect, not up, down, or left, right. Even the seesaw, because I had some of my students comment on that. The seesaw has a center line which is controlling the balance left and right. If the person is going, we say up and down, but they're really not. They're going this way or that way on this side, this way or that way on that side. So this is a turning effect. It's not up or down. Now, what is the moment of equation? Moment depends on two things. It depends on the force and it depends on the distance. So the size of a moment is defined by the equation moment is equal to force times the perpendicular distance. Now, why do we say perpendicular? I'd like to explain each word that we say, because if the force is applied like this load over here, it's applied down. My distance will not also be down, it will be perpendicular. Okay, until I reach the pivot. So moment is force times perpendicular distance. For example, on a horizontal beam, the forces which will cause a moment are those directed up or down compared to the distance to the pivot. Here, I'm going to put the triangle like we always do. Moment is up, and I like to put it as a capital M because small m, we always refer to it as mass. So capital M, capital F, and D. Knowing that force is in newtons and distance is in meter, so the moment will be in Newton meters. If the force is also in newtons, of course, but the distance is in centimeters, then my moment will be in Newton centimeters. So be very careful with the units. Here's an example. Pause the video, try it on your own, and then unpause to check your answer. A person pushes a door with a force of 20 newtons at a point 0.8 meter from the hinges. What's the moment produced? We're going to use our equation. Moment is force times distance. So 20 times 0.8 is 16 Newton meter. Okay. Next example. Pause the video, try it on your own and unpause. Two people apply the same two people. 50 Newton force to loosen a knot using different spanners. Person A uses 0.1 meter spanner. Person B uses 0.25 meter spanner. Who produces the greater turning effect? We took that moment as force times distance, and since they're both applying the same force of 50 Newton, so we're going to use 50 for both of them, but person A will use the distance as 0.1, person B as 0.25. So here's the answer. Person A's moment is 5 Newton meter, person B 12.5 Newton meter. So my answer will be person B creates the larger moment because the distance from the pivot is greater. Now let's talk a bit further about the moment of force. We said that the moment depends on force and distance. Increasing the distance a force is applied from a pivot decreases the force required. That means that the further I go, the less force is required to make this object turn. The closer I go to my main point, to my pivot, the more force will be required to do the turning effect of that door or of that object. So if you try to push open a door right next to the hinge, it's very difficult as it requires a lot of force. If you push the door open at the side furthest from the hinge, then it's much easier as less force is required. We agreed that it's a turning effect, so we need to know which direction is it going to be. If I said not up, down, left, right, then which direction is it going to be? Clockwise and anti-clockwise. Just remember how the clock works. So as the blue arrow represents the clockwise and the green arrow represents the anti-clockwise. Now let's take actual examples and compare. The principle of moment states that for an object in equilibrium, what do you mean by equilibrium? Equilibrium means balanced. So if the object is at equilibrium, that means that the moment on the left should be equal to the moment on the right. So the total clockwise, which one is clockwise? 2 or 1? 1 should be clockwise, right? Or 2? Of course, 2 is clockwise and 1 is anti-clockwise. So total clockwise moment should be equal to the total anti-clockwise moment. This applies to any system where forces are causing rotation about a pivot point. So therefore, as we can see, if this condition is not met, the object will rotate. What do they mean? They mean that if both moments are not equal, they're not at equilibrium, then the object will rotate either clockwise or anti-clockwise depending on which moment is larger. How to use it? Number 1, choose a pivot point. Number 2, calculate the moment of each force by using moment equals force times perpendicular distance to the pivot. Number 3, use the equation clockwise moment equal anti-clockwise moment. Number 4, solve for the unknown. Let's take an example and try this out. Pause the video, try it on your own, and unpause to check your answer. A 2 meters long uniform beam is balanced on a pivot at its center. So the whole thing is 2 meters long. A 30 Newton force is applied 0.8 meters from the left, where 20 Newtons force is applied on the right. Where must it be placed? So where, then they want the distance. I know that on the left, my moment on the left should be equal to the moment on the right. Moment is force, let's call it F1, times distance, D1, equal to the moment on the right, let's call it F2 times D2. I already have the F1, which is 30 newtons, D1, which is 0.8. I have the F2 as 20 newtons, but I do not have the D2. So remember, because I have a lot of students that have a problem with cross multiplication, if I want the D2, then everything next to it has to go to the bottom part of the other side. So I'll move the 20 newtons to the left. So here we are. The 30 times 0.8 is giving me 24. So the D will be 24 divided by 20, giving me 1.2 meters. Okay? So I need the distance of the second, of the right side of the equation to be 1.2 meters in order for the beam to stay balanced. Here's another example. Pause the video, try it on your own, and then unpause. A uniform beam is 3 meters long and pivots at the center. On the left, 15 Newton force is applied, 0.5 meters from the pivot. And so there's a second force on the left. 10 Newton force is applied, 1.2 meters from the pivot. So on the left, I have two forces, 15 at 0.5 meters and 10 at 1.2 meters. On the right, there is only one single unknown force, which is 0.9 meters from the pivot. What's the value of F to balance the beam? Can I just add the forces 15 plus 10 and 0.5 plus 1.2? No. You need to find the moment for each and then add those moments together. So 15 times 0.5, that's the first moment on the left, plus 10 times 1.2, that's the second moment on the left, should be equal to the moment on the right, which is 1.2 times, which is 0.9 times f. So what he did is he found all the moments that are on the left, giving 19.5 Newton meter. And now he's looking at all the moments that are on the right, which is, we don't know the force, but we know the distance, 0.9. So f times 0.9. So what he's doing here, he's doing the moments on the left equal to the moments on the right. I already have here the moment on the left. So I'm going to do the moment on the left equals to the moments on the right. To find f, again, I want f, so everything next to it should go to the other side at the bottom. So f is 19.5 over 0.9, giving 21.7 newtons. There's a third example. Pause the video and unpause when you're done. A 25 Newton force is applied 1 meter to the left of the pivot. What distance from the pivot should 20 Newtons force be applied on the right? I need to find the distance. Again, I'll do the moments on the left equal to the moment on the right. And of course, we know that the moment on the left should always be anti-clockwise, and the moment on the right should be clockwise. So the moment on the left, we're going to find it, which is 25 times 1, and the moment on the right, which is 20 times d, because we're trying to find the distance. We do not want the 20 next to my d, so it's going to go down. So d will be 25 over 20, giving 1.25 meters. Equilibrium of an object. An object is said to be in equilibrium when both of the following conditions are satisfied. When there is no resultant force acting on the object, that means that all forces are equal or all forces cancel out. And there is no resultant moment acting, that means that the object is not trying to rotate. In equilibrium, the object will stay at rest if already at rest, and it will move with constant velocity if already moving. May I remind you, which Newton's law does this reinstate? First law, Newton's first law. If you can't remember, you can go back to the first video on forces about effects of forces to recall that. So the object will not start rotating or change its rotational state. Thank you so much for watching. Please leave your comments if you have any questions, and I'll be seeing you in the next video. Have a good day.